So this one just starts, section 2.3, day 2, real zeros. So you're actually going to be solving once we get down here, you are, okay? But up here, this is just an exercise just to get you practicing your algebra, to be honest. So this says degree 3. We'll come back to that in a minute. I'm questioning whether or not they needed to tell us that, because watch. If they tell us that these given degree and zeros are -1, 2, and 3. We've done these before. So this is f of x equals x plus 1, x minus 2, x minus 3. That way I can look at this and go, yep, if this is the way it was written, I could conclude that those are my zeros. But look at what it says right here. It says with leading coefficient. So again, this is just an exercise, so don't get too headstrong and try to figure out what this is all this means. Don't worry about that too much. We're going to FOIL this out. X squared minus 2x plus x is minus x minus 2. And now we need to multiply that by x minus 3. Now, when I get to here, I just like to go like this. So it's my 3 by 2 box. X squared minus x minus 2, x minus 3, and now x cubed minus x squared minus 2x, negative 3x squared plus 3x plus 6. Now look for your like terms. So there's that guy's all by itself. So it's x cubed minus 4x squared plus x plus 6. And I'm done. Oh, no, you're not. Because this says you're not done until you have a leading coefficient of 2. What's a leading coefficient? Well, this is my leading term because it's the highest degree. So I'm just going to multiply everything by 2. So 2x squared minus 8x squared plus 2x plus 12. And that's my final answer. You're just kind of obeying instructions. All right, let's try this one. Slightly different. Oh, back to this question. If I have 3 answers, isn't that the way they're telling me? That oh, look at this. Look at that. Caught my mistake. That my highest power is going to be a 3. We know that from previous lessons. So they didn't really need to tell us that, but hey, we'll take it. This says degree 4, which means in our answer, the highest power is going to be a 4. Well, that will take care of itself naturally. So h of x equals, so really you're going minus, you're taking away that, answer, and then you're doing the same thing here, minus the answer, and then when you have a 0 for an x, that's like having an x right out in front. And then you take away your answer. I'm just showing every step. So these would turn into pluses. That would stay a minus. And so here we go. Now I'm going to go ahead and, a lot of students ask themselves, if I distribute this through, do I go through everything or just one of them? And the answer is just one. I'd take time to prove it if I didn't have a timer on me right now with this video. So it's x squared plus 2x. And now I'm going to just keep working my way down here. I'm ignoring this for a second. That'll be the grand finale. So I have to FOIL this out. I'm going to go old school. X cubed plus x squared plus 2x squared plus 2x. I'm going to clean this up. X cubed plus 3x squared plus 2x. I still need to multiply that by x minus a half. All right. Now, I could outthink this a little bit. Rather than having to multiply all of this by this, you remember how I had to multiply everything by 2 over here? I'm going to multiply this by 2 because then I can see down the road it's going to attach a 2 to this. So I'm going to double this. So I'm going to go x cubed plus 3x squared plus 2x. And then I'm going to go, aha, 2x. What's 2 times 1/2? And man, did that make the next step a lot easier. So I'm going to make a 3 by 2 box. Here it is. x cubed, 3x squared, 2x. 2x minus 1. So I get 2x to the fourth, 6x cubed, 4x squared, negative x cubed, negative 3x squared, minus 2x. And my final answer I'm going to write up here. I'll slide it right down here. So h of x equals, that guy is all by itself. Got some like terms here. Got some like terms here. That'd be 1x to the second power minus 2x. And there you have it, with a leading coefficient 2, because we took care of it by multiplying that by 2. A little math trickery. Or you could have multiplied this by this using one of these crazy things, deal with that fraction work, and then take your answer and just multiply everything by 2. Either way. Okay. You always hear me say meat and potatoes. This for sure is meat and potatoes. This says, use the rational zeros theorem. Now let's read these instructions carefully. To write a list of all potential rational zeros. Then determine which ones, if any, are zeros. All right. So we got to use our plus or minus p over q. Remember in the pre-lesson I said you didn't need to bring the plus or minus down below here. This technically says, yeah, it's plus or minus p over plus or minus q. But pre-lesson, I showed you, you only need the plus or minus in the top. So the 12 is where I'm going to get all my factors of that. That's what represents my p. So plus or minus 1, 2, 3, 4, 6, and 12. And then you love it when that's a 1, because that's what this is. So if we put all of this over 1, it doesn't change a darn thing. That's going to change on this example. That's going to make our lives a little messy. But what this means is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12 all have a chance of working. How do you know? Plug them in. So we're going to try f of 1. Try to do some mental math here quickly, because it takes a while. I think that was a plus. Yes. Plus 12. So I ask myself, does this have any chance of being a 0? No. I can just look at it. These will not add up to 0. So 1 is done. Negative 1, better be careful of the negatives. Negative 1 squared is 1 times negative 4 is negative 4. Negative 1 times negative 3 is 3. Plus 12, that's 15 minus 5. We're looking for something that equals 0. So yeah, this is going to take a lot of work. Some of them do. 2 cubed is 8. 2 squared is 4. Times that is negative 16. 2 times that's negative 6. Plus 12. That's negative 22. This is positive 20. So close, but yet so far. Negative 2 cubed is negative 8. Negative 2 squared is 4. Times negative 4 is negative 16. Negative 2 times negative 3 is 6. And then plus 12. This is 18. This is negative 24. See, this is just a lot of work. And so we go in here. And so then we say, hey, we got to find 3. And so we go 3 cubed is 27. And then 3 squared is 9 times negative 4 is negative 36. 3 times negative 3 is negative 9. And then plus 12. Look at this. This is 39. This is negative 45. Sometimes this happens. Negative 3 cubed is negative 27. Negative 3 squared is 9 times negative 4 is negative. Looks like we're going to have way too many negatives. Plus 9 plus 12. Again. Running out of time here. 4. What's 4 cubed? That is 64. What's 4 squared? 16 times negative 4. Uh-oh, looking good. What's 4 times negative 3? Negative 12 plus 12. Wow. Boy, was that a journey. Does that equal 0? Yes. What does this mean right here? It means that plus 4 is one of our rational roots. Now, I might be jumping ahead a little bit, but why not? Now, I'm going to I'm going to hit pause a second. All right, so I was gonna use synthetic division right now, but I don't think that's what the intention of this is. Because later on, we're gonna use this, and we're gonna use synthetic division by putting it in the chipmunk nest, and then that will produce the other two answers. How do I know there's two answers? Because that's a 3. Remember, if that's a 3, we're gonna have 3 roots, or 3 zeros. If that's a 3, we're gonna have 3 roots, 3 zeros. So we're just going to keep on going and see what works. So we're going to plug in -4, and we get -4 cubed is -64. I got to save some space. -4 squared right there is 16, plus that is -64. Can you already see that we're going to have way too many negatives? And then I got to go to 6. And so I'm going to try f of 6. And so 6 cubed is 216. 6 squared is 36. 36 times 4 is 144. So that's minus 144. And you can already see we're going to have way too many positives. And take my word for it, if we put 12 in, there's no way that's going to work. And if we put -12 in, that's not going to work. Okay, so we found one rational root. That means the other two are irrational. So let's go to this one, okay? Because that's all we want to talk about. Later on, we're going to find the other two answers that exist, and that's why I paused it, just to make sure that that wasn't expected of us today. So, all right, let's use the rational root theorem for this bad boy. So, plus or minus p over q. Good news. That's a 3. Now, I can ignore that negative because it's plus or minus, so it's going to be plus or minus 1, plus or minus 3. That's such good news. We don't have this huge list. Problem is, it's over 2. What are all the factors of 2? Plus or minus 1, plus or minus 2. So what does this really produce? Well, if I only concentrate on those, it'd be plus or minus 1, plus or minus 3. But then I'd concentrate on 1/2, which is plus or minus 1/2. And then I would concentrate on this, which is 3/2. So that'd be plus or minus 3/2. And literally, you just have to plug them all in and figure out which ones work, which ones don't. I've only got, about 2 minutes left, so I got to kind of hustle. If I don't finish, I'm just not going to finish. So f of 1, 1 times 1 times 1 is 1 times 2 is 2. 1 squared is 1. Plus 5 minus 3. Look at it. That's 8 minus 3. That does not equal 0. What about -1? -1 cubed is -1 times 2 is -2. -1 squared is 1. -1 times 5 is -5. And that's minus 3. Way too many negatives. It didn't work. How about 3? 3 cubed is 27 times 2 is 54. 3 squared is 9. Can you already see we have way too many positives? -3 cubed is -27 times 2 is -54. -3 squared is 9. Again, now we got too many negatives. And we're forced to dive into fractions. And I've got 1 minute. 1/2 cubed is 1/2 times 1/2 times 1/2, which is 2 times 1/8. 1/2 squared is 1/4. 5 times 1/2 is 5/2. Minus 3, and this thing just looks like a disaster, but watch this. 2/8 reduces to 1/4 plus 1/4. I'm going to find common denominators and say 10/4 minus, watch this, 12/4. Isn't this 12/4 right here? So what's 12/4 minus 12/4? That would be 0. After all that crazy work, I found one, and it's 1/2. And I don't have time to plug these in, but I don't think the other ones work. So I think that's our only one that works. But if you were kind of like on a test or a quiz, yeah, I would plug in the -1/2, the +3/2, -3/2. But that's the end of this 15-minute recording, so I got to hit stop.